Hello AP Physics students. So for tonight's homework, I'm going to actually show you another video about pulleys, and I'm going to show you how to approach this problem with two hanging masses, and you're actually going to just finish the web assign that was due already, that's now due tomorrow, and I'd like you to make a couple more predictions on the back of your lab worksheet. So tomorrow we're going to do that lab again, just as extra practice, because that's what I can tell we need. So let me show you how to approach this, all right? Remember that in these problems, we're kind of dealing with a line of force or an axis that sort of bends around the pulley, right? So if we want to actually draw this, with the x-axis sort of stretched out like this, here's our 500 gram mass, here's the 200 gram mass. Really the forces look like this, right? There's some mg, it's a little less mg, there's some tension. Tensions are equal because of Newton's third law. But if we kind of stretch it out into the same axis, it ends up looking more like this. So there's mg, and maybe we want to call this m1. And this is m2 for the sake of our algebra, right? And there's a smaller m2g, and then there's these tension forces that are balanced. So when we consider the system of both objects, the tension forces, they're internal, like they don't matter, right? If we want to look at the entire system, they sort of, you could say they cancel out, but they still exist, so they don't really cancel out, right? They're just internal to the system. So if we draw a free body diagram for our system, if this is the system of both objects, all we've got is m1g going this way, m2g going this way. And if you have to follow these steps if you want to get to the right equation. There's no one equation for problems with pulleys, and because there could be friction, there could be other things going on. All right, so let's start with Newton's second law, right? So we have a net force expression that looks like this. The system's going to accelerate to the left, so let's make the left positive, just for the sake of making it easy on ourselves. All right, now we want to know the acceleration. All right, acceleration is net force over mass. But what mass? We're looking at the system, right? So this is going to be both masses, right? It's going to be like m1 plus m2. So the actual formula you're going to end up with when you put this all together is m1g minus m2g over m1 plus m2. So when you solve this, you'll get an acceleration of 4.2 meters per second squared. And that you can use to make a guess about the tension. So let me show you how you do that. All right. Give me a second to make a new thing. Insert blank page. All right. So, all right. Our acceleration was 4.2 meters per second squared, right? And we have, again, this system that looks like this, right? This is our 500, this is the 200. Okay, we want to know the tension in the rope, right? The tension in the rope. It's internal to the system. So what do we have to do? We have to pick a different system, right? Because each one of these has two forces on it, mg and the tension. We could pick either one. So let's just pick this guy. If I draw its free body diagram along this x-axis, it looks like this, right? And this is 500, right? The 500 one. So the net force expression is going to look like this. Remember also sigma F equals ma, right? So let's put that over here. So we have ma equals mg minus t. But again, which m are we talking about here? We're talking about the 500. That's the one we focused on, right? M1. So really this is M1A, M1G, right? So if we do this algebraically, the tension is going to be M1G minus M1A. And when you substitute M1, 500, oh wait, it's not 500, right? 500 grams is 0.5 kilograms. So make sure you do that conversion before you plug stuff in. But what you'll get here is 2.8 newtons. All right, So that's 5 minutes, so I'm going to stop there. You're going to do this twice on the back of your worksheet following the instructions below this video. All right, thanks for watching.